Technical cleanliness is a discipline of quality assurance dedicated to locating and classifying contaminant particles which could pose threats to the safety, compliance, and performance of a product. The most effective way to characterize particles spanning micron to submicron sizes is using a scanning electron microscope, or SEM, with energy dispersive X-ray spectroscopy, or EDS. But analyzing large areas for contaminant particles can be monotonous and time-consuming. The Thermo Scientific ParticleX uses Perception, a software package that sets up automated runs and analyses. It includes locating, counting, measuring, and classifying each particle of interest. This video will demonstrate how to set up a run properly and analyze the data. This is Perception on a ParticleX-activated Phenom XL. On the screen is a navigation camera window showing the sample holder. This allows the user to create a stage file, which assigns the location for technical cleanliness analysis. This holder has a capacity of 4 47mm filters, but other holders can be used to look at 25mm filters or standard SEM stubs. The controls for beam settings, like accelerating voltage and beam intensity, and imaging settings, like magnification and focus, are located in the left panel. The SEM Live View updates as settings are adjusted in the left panel. The right panel is where we create the stage file. To define a sample area, the user can select the area type and click and drag over the sample stubs that should be included in the stage file. Existing stage files can be opened and modified for quick setup.
Auto tasks can be used to standardize the analysis for all users. An internal reference standard is used, which has aluminum, carbon, and copper. For consistent brightness and contrast throughout a run, an auto video task is configured. Select a point on the stub in the navigation camera window. In the SEM Live View panel, click to navigate and scroll to zoom and find a clean area that has both aluminum and carbon. Align the interface of the two materials in the field of view. This step ensures that the brightness and contrast remain consistent throughout the run. The same workflow is done on copper to set the point for auto EDX calibration. The stage file, including the reference sample, can be used as a template for future runs. Save the file and switch to the recipe builder. Recipes allow the user to build various fully automated functions, like the auto video task shown here. The recipe features include many options, such as EDX calibration, beam settings, power state, and quality control checks. For example, an autofocus task is added to minimize user input for a filter analysis.
A pre-made morphology rule file is loaded to designate which particle sizes and shapes will be accepted for analysis. Other settings that are required for a successful run are classification rule files, which assist in categorizing or classifying each particle based on elemental composition or morphology, and the threshold settings allow users to set the brightness of the particles of interest for detection and measurement. The dual threshold algorithm that Perception offers detects particles quickly and gives users confidence that they are measuring the particles accurately. Once these settings have been defined, a recipe can be saved and reused for every analysis moving forward. Under the Automatic Feature Analysis tab, a recipe file is loaded, with fields for notes or other information about the sample. Clicking play starts the fully automated run. In a typical workflow, the Phenom automatically views the auto video sample to adjust contrast and brightness. If an autofocus task was inserted into the recipe, it will look for particles to focus on to set the working distance. Then it moves field by field, searching for particles that fit the criteria in the morphology rule file. When particles are found, the size, shape, and elemental composition of each particle is stored. The system will display images and collected EDS spectra to classify the particles by their chemical composition. After all fields have been scanned, the run ends. Particle Selector displays the raw data. Each row has a different particle, which contains an image, elemental composition, size, and particle classification. Particle coordinates are saved for revisitation for further EDS analysis at any time with a single click. Perception Reporter is for customizing templates and generating data reports. These templates can be added to the analysis recipes so reports are automatically generated once the analysis is complete. The generated Technical Cleanliness Report is organized into multiple sections. It includes an ISO 16232 and VDA 19 results tables with pass-fail results. This table can be normalized to 1,000 centimeters squared or 100 centimeters cubed per ISO 16232 specification. The classifications of the ISO 16232 table can also be color-coded based on hardness or conductivity. A histogram table of the particle results shows size classes and total counts. There is also a stage map showing all the particles that met the individual particle parameters set by the Morphology Rule File. The report ends with a particle table, which shows the top particle based on the morphology parameter. Shown here are the 10 largest particles based on maximum diameter. The table includes a picture and data such as size, width, class, and roundness. Thank you for watching this demo of setting up and performing a technical cleanliness run on perception with the Thermo Scientific Phenom ParticleX Desktop SEM. For more information, contact us at nanoscience.com.